Welcome to the Flux Dev Meeting for December 15th. Not quite the last dev meeting of the year, perhaps, but getting close. If you have anything else for the agenda that's not on the agenda doc already, please check out the doc and let's get started. The first topic on the board is the review for current GA dev focus. Paulo, are you in a position where you can narrate this for us?
Yeah, sure. Let me try to get my machine working here, and I'll share my screen in a second. Can you see my screen?
Yes.
Brilliant. Okay, so all right. Yeah. So if we go to the Bootstrap GA, which is what we generally do, and we go through the ones that we closed since the last dev meeting. So there is a fix for the recurse submodules. I think we kind of briefly talked about this last time. And basically, when we did the Git refactoring, one of the hangovers from that was that folks using recursive modules were getting an issue, which is now fixed and confirmed by this user, which is great. Some improvements on proxy tests as well that Sanskar worked on recently. Another issue, which I'm pretty sure we also mentioned before from the Git refactoring, was Flux CLI in some specific cases were erroring. That is fixed. We haven't released those fixes yet, but we're planning to do that this week. So let me move that across. Let me just open this. All right, yeah, so this was actually not an issue. It's just that a user trying to use GoGit, or an older version of source controller to access Azure DevOps, and that is not supported. You must be on the latest for that to work. So that is no issue. Then there is a bunch of kind of related stuff. I'm just kind of moving there so we're not talking about the same thing twice. Around libgit2 and git2go, as we discussed before, we are decommissioning the whole libgit2 from the code. We kind of fast track that because the build was not working. So just to make sure that we had a working build without wasting too much time with libgit2, we pretty much remove all the dependencies, which, to be honest, is really good. It's going to be a lot easier for us to maintain the project going forwards now that this is all gone. So that is that. There was, well, this fix shell root file system is related to the recurse subsystem and recurse submodules that we talked before. We can discuss these other three. I'll just open them quickly. Yeah. Yeah, so this Bootstrap fallback to default no host. This is the fix for the CLI we discussed, probably the first item we discussed. So it's just kind of correlated. These are a few more tests. Now we have an end-to-end test for Bitbucket server as part of our package and repository, which, again, the idea is to have as much of those tests within FluxD package, so we can make sure that everything's working there before we start distributing the latest package into the consuming projects. And last but not least, we introduced Git shallow clone feature, which allows for image automation controller to do shallow clones instead of full clones. This is really positive, especially from a resource optimization perspective, and also fixes a an issue that a user reported, in which by upgrading to the latest of image automation controller, they noticed a lot more resources being consumed. And the reason for that is, as we probably mentioned in a few sessions before, we're using GoGit. GoGit will churn into a lot more memory than libgit2 would, especially if you're talking about the entire repository. Now that we're doing shallow clones by default in both source controller and image automation controller, that should not be a problem at all. All right, I think that is it for the items we've done. Well, maybe there's some things here on the backlog that are not directly related to the GA. But yeah, I think we discussed this before, the rolling out of new standards to notification controller. We update notification spec documentation. This is related to the first notification controller that I mentioned. There is a bunch of fixes around fuzzing. I will not talk about this right now because I have an item on the agenda to discuss this, so we can just talk about that later. And then there are some fixes around OCI package, and yeah, this OCI package, and then Git end-to-end test as well. There was some issues that we had to fix, and that is pretty much that from since the last session.
Super. So next on the agenda then, I think we talked about both of the first two items. Then it's Thomas or Florian.
All right, thank you. Then let me just share my screen. All right. Can everybody see my screen?
Yeah.
Yes.
All right, perfect. Oops. Everything a bit laggy today. All right, yeah. So first of all, thank you very much for letting me speak here today in your community meeting. My name is Florian Bacher. I'm a maintainer on the Captain project. And today we would like to, or I would like to present you what we're currently working on, which is the Captain Lifecycle Toolkit, and how we aim to build up upon the GitOps concept, and how we can maybe contribute to that and build up upon that. And hopefully this might be something that you could also use in your work. And of course, we're also looking always for feedback on what we could improve or how we could further improve the compatibility with other projects such as Flux, for example. All right, so without further ado, let's jump right in. So I don't think I need to sell GitOps to any of you, but maybe a couple of highlights that we found are really cool about GitOps and why we think it's the way to go. So first of all, it's of course nice to have a declarative state in a versioned way with all the Kubernetes manifests that live in a GitOps repository, which represent a clear description of how you actually want your application to look like. Then, of course, the automatic reconciliation of the manifests that live in the GitOps repository is, of course, a great approach, which I think makes everybody's life a little bit easier. And then, of course, with the GitOps being the repository being the single source of truth, it makes everything much more traceable in terms of what has changed in the configuration of your application, and potentially also makes it easier to roll back to a previous working state using the commit history. And all in all, it just feels like the natural way to deliver apps in Kubernetes. But also we found some challenges that might still be worth tackling. So let's quickly talk about those. So, of course, whenever you want to deploy your latest state of the application, you of course would like to make sure that your infrastructure is actually ready to deploy. So for example, by checking your error budget or making sure there are no open problems within your infrastructure and so on. So because you wouldn't necessarily want to deploy a new version in a broken cluster, right? Then we would like to make it a little bit easier to kind of add additional checks for certain prerequisites when deploying an application. So for example, checking if an external service that our application might depend on is already available, and make that a part of the deployment process. Then we would like to have some sort of traceability of what is actually happening during the deployment of a new application version. And then we would also like to make sure that everything is up and running smoothly after the actual deployment has finished. And out of those kind of challenges, we have derived a couple of use cases that we want to provide with the Lifecycle Toolkit. So now let's jump into that. And maybe before that, a quick look on the basic principles that we kind of always keep in our head when working on new features for the Lifecycle Toolkit. So first of all, you would like to enable the use of that with minimal configuration effort. We want, of course, to be GitOps aware and pipeline and enable a pipeline-less delivery of applications. So we want to be compatible with all the awesome GitOps solutions that already exist and cooperate with them. Then we would also like to make it as easy as possible to incorporate external tools into the deployment process. That could be, for example, monitoring providers or task executioners that, for example, execute simple JavaScript scripts during the deployment tasks that you're going to see shortly in the demo. And we want to give deep insights into your deployment process by providing traceability of what's actually happening during the deployment. And we want to do this in a cloud-native way. So the toolkit is implemented as a Kubernetes operator using custom resources that then can in turn live together with the rest of your application within a GitOps repository. And yeah, maybe a few comments about observability. So we are using OpenTelemetry. So basically, our operator provides all sort of different metrics that might be of interest, like the number of successfully or failed application deliveries, then the time between those, and the currently active deliveries of your application. And this is exported to the OpenTelemetry collector, and this can in turn then be used by Prometheus or Grafana, as you can see here in this dashboard example, where we both have these metrics. And in addition, we also provide traces, which I'm going to show you in the demo shortly. And yeah, here on the right side, there is actually a little teaser of how that will look like. So with that, we aim to make it more comprehensible what's going on during a complex application deployment, right? And since I said we want to make it as easy as possible to actually use it, we found an approach of supporting the the Kubernetes recommended labels to enable the lifecycle toolkit, let's call it injection into your application. And you're going to see how to do that in a few seconds. But first, let's also talk about the integration of external tools and pre and post deployment checks. So basically where we hook into is, as I said, we implemented everything cloud natively using custom resources, using the operator pattern. So here the most common denominator is basically everything that does kubectl apply pretty much. So for example, Flux or Argo, etc. And as soon as that is the case and you opt into using the lifecycle toolkit for an application deployment, we enable you to do pre-deployment checks and evaluations during or before the workloads are actually being rolled out. And we provide extensibility with custom functions. So we have a functions runtime that supports right now Node.js, but maybe it would be worthwhile to further support additional languages where you can add simple functions that should be executed during your pre or post deployment checks. So a post deployment check could, for example, be sending a Slack notification informing you that the application has been rolled out. And you will see that also in the demo shortly. And we also, out of the box, support the so-called Captain evaluation definitions. So here you can, for example, provide any Prometheus query, like, for example, the number of available CPUs, and evaluate against a certain target. And based on that, you can then say, okay, if that is not met, then I do not want to proceed with rolling out my application. All right. Now for the demo, we are going to deploy our beloved Potato Head, which is a kind of a microservice showcase application consisting of different services like the right arm, right leg, and so on, and the entry service. And in our example, we would like to add a pre-deployment check for all the services other than the entry service, which then in turn will only be rolled out once the entry service is up and running. So that would be the pre-deployment check that we want to show you here. And also we are gonna add an evaluation that checks for the available CPUs, as I just said before. So we want to make sure that we have enough resources to run our application actually. Not the recap. Now let's jump into the demo. Okay, so here we have a couple of custom resources. So first of all, we have our Captain app, which is one of our custom resources. So here you basically describe what services you want to include into your application. And those are exactly the microservices of the Potato Head application. So we have the left arm, left leg, entry, and so on. And once our application has been rolled out, we want to send a Slack notification. And yeah, and here in version 1, we also want to make sure that we have the required number of CPUs using our evaluation definition, which is, let me check app pre-deploy. Yeah, so here's an example of an evaluation definition where we check against this Prometheus query. And then finally, let's look at the actual deployment manifests. So those are all pretty much the same, but maybe let's no. Sorry. Yeah, sorry. Here it is. So basically, the way how to enable the lifecycle toolkit for your workloads is to add the Kubernetes recommended labels, like the part of the name, and yeah, those two. So if you have set those, then it will check whether, or it will correlate the deployment to the application custom resource that I showed you earlier. And now let's just go ahead and deploy a version 1. All right, so everything is being created and reconciled. And here in Lens, let's go into the Potato kubectl namespace. You can see that all of the pods are in the pending state, which means that the Captain Lifecycle Toolkit scheduler is currently not allowing them to be scheduled onto a node because the evaluation criteria is actually not met. So let's go here to the Captain evaluation. And here we have implemented a retry mechanism. So it's retrying the evaluation for 10 times before it will eventually fail. And therefore, the pods are not going to be scheduled. But instead of looking at that in Lens, we also provide the Grafana dashboard. And here we have our example trace of that. And within a couple of seconds, this should be, yeah, we should see a little bit more here. And in that case, we see that the pre-deployment evaluation has failed because we achieved a value of 1.2 for our available CPUs, but we checked for that value being greater than 4. And yeah, as you can see here, this trace makes it easy to see where exactly that deployment has failed. And in a more complex application, this might help one to tackle down the problem where your application deployment failed. But now let's show you a working example. So now we're going to deploy version 2, where we have a more reasonable target for our available CPUs. And yeah, now that's running. And let's go back in our dashboard. And we already see the new trace. So now we have seen, now we can see that we have passed the pre-deploy evaluation phase. Maybe let's make that a little bigger. All right. And after some time, new OpenTelemetry spans should pop in, and eventually we will see the complete deployment. Maybe let's have a look at our running pods in the meantime. Exactly. So as you can see here, all the pods other than the potato head entry are currently pending, or actually the potato head is currently, yeah, this one's currently initializing. And as soon as that is up and running, then eventually all the other pods should be scheduled as well. So let's hope the demo gods are happy with me. So currently it might take some time because we do this by creating a job that checks for the availability of the potato head entry. And if that is failing, we need to wait for the next restart of that pod to kick in. So this is something that is a little bit clumsy right now, but eventually we would like to make that a little bit smoother as well. Let's refresh that.
In the meantime, oh yeah, well, go for it.
Sorry, there was a question.
Yeah, I was going to ask a question in the meantime, but I can ask later. It was mostly to pass the time and while we're waiting for that to come up. I can ask later.
All right, perfect. Then I will keep that in my head. But now the pods are popping up and are up and running. And now we can go back to our trace. And this will hopefully now look kind of like a Super Mario level. But this will then give a nice visualization of what has happened during the deployment. So for example, we have the potato head entry here. And here we had a very short workload pre-deployment and evaluation phase because we didn't have any checks in there. But then the deployment where the pod was being scheduled and waiting to be up and running. And then once that has been finished, the other services were able to finish their pre-deployment check where they were waiting for this other service to be up and running. And hopefully we now even got, we also got the Slack notification, which has been sent using our, where do we have it? Post deployment. Yeah, so here we provide a function that's being hosted on GitHub in a source file where you can pass the reference to a secret containing the Slack token. And using that, it enables you to send a Slack notification that your deployment has been finished. All right, and that concludes my demo. And now I'm happy to answer questions if there are any.
Well, I had a quick question. So I saw that, you mentioned something around having the checks created as jobs. Is that part of the application itself, or is it part of, the infrastructure of Captain?
The jobs are being created by, let's see, so here we have, exactly. So with the Lifecycle Toolkit, we provide the Captain task definition custom resource. And that currently supports simple Node.js or JavaScript functions to be executed. And this one, or the controller for that custom resource, will basically create a Kubernetes job with our runtime as a container image. And within that image, this function that's being referred to is going to be executed until it's either successful or until it has failed, I think, for 6 times, which is the default retry value for Kubernetes jobs.
Nice. Another question as well is, like, in the beginning you mentioned, the idea of the toolkit is to also integrate with things that also manage GitOps. So how, what would it look like to have some Flux stuff integrated with this? So for example, if I had some Git sources or like Helm releases and so on.
Yes, so the plan would be that those custom resources that that we have here, like the Captain app and so on, and optionally also the tasks, those could live within the Helm release of your application, right? So this way you would have the possibility to then enrich the application of the Helm chart also with the execution of those functions. by first of all annotating the namespace with being enabled for the lifecycle toolkit. But we are also working on an epic in the near future where we provide an auto discovery pretty much of a Captain application by just annotating the namespace appropriately, and then based on the Kubernetes recommended labels, for example, we can then reconstruct also or do an auto discovery of what in that case would resemble a Captain application. But I guess the short answer would be that all those custom resource objects would live in the same Helm chart as the application that's being applied. Did that answer the question?
Yes, thank you. Thank you for that. That's I think that's all my questions. I just wanted to say that I quite like the whole idea of the workflows and also being able to set evaluations and so on. That's pretty neat.
All right, thank you. Okay. With that, I'm at the end of my presentation. Thank you all for letting me speak here today. And of course, we are always welcoming any feedback. And if you have any questions or would like to contribute, we are also always happy to look at your PRs or to answer questions in the CNCF Slack Captain channel. And yeah, hopefully you could take away a little bit from this presentation, and thank you for your attention.
Thank you. That was very interesting.
Thank you.
Okay, next on the agenda, we have Paulo with Flux Fuzzers.
Yes, well, I think this is pretty much a topic that keeps coming back. But yeah, I just wanted to kind of cover pretty much where we are right now and changes that are taking place as well. So first of all, I actually want to just cover one issue. So recently we had some of the fuzzers stop working completely at both, our projects and also at upstream on the OSS fuzz, right? And the reason for that is that we have quite a bit of custom code, or we had quite a bit of custom code to make the fuzzers to build in a very lightweight when we actually working within the projects, right? Because upstream there's a lot of infrastructure, there's a lot of moving parts that pretty much we don't need when we're just doing some sort of smoke test just to make sure things are working before we create a PR, for example. So I created this issue here to pretty much enumerate the key things I wanted to do to get the whole thing into a better place. And most of it is done. And the idea there is pretty much to consume as much of the code upstream as possible. So what I'll do right now is pretty much walk through how this works, and then also some ideas of the outstanding things that we need to do to improve. So the first thing is the fuzzing implementation we have is pretty much the native Go fuzzing. But as we're integrated with Google OSS Fuzz, there are a few specific things we need to do, right? So for example, the configuration upstream is pretty much based on a Docker file that defines what you need to kind of get the base image to build your fuzzers, and then you need a script to pretty much build it, right? given that we have several repositories, and it's quite a different approach than most of the other projects implemented or integrated with Google OSS Fuzz, what I've done there was to enumerate our repositories, and then the base image actually do a shallow clone of all of them and pretty much copy the build file. And then at the startup time, it will pretty much run the build file and get everything working. Cool. Quite nice and straightforward. In terms of the build script, it is a bit more involved. And the idea of this guy is to be a bit more dynamic. I think, let me see if I have an example here in Go, just to show what people generally do. So people generally do like a compile Go fuzzer for every single target they have, right? So for every time they add a new fuzzer on their project, they need to do a PR into OSS Fuzz and add that the new fuzzer targets that, which it just doesn't work for us. So what this build.sh does is two things, really. So one, which is a default here, is look through all the repositories on the org, right? So for example, if our Docker file has, in this case, I don't know, I think it's 7 repositories, you just look through all of them and try to kind of build each one of those. If you only have one, then just one. So let's go back there quickly. And then as it loops through, there are a few specific requirements that needs to meet. I'm not going to go through all the details, but just wanted to kind of highlight a few things. So for example, we have some dependencies that we don't want you to add into our code directly because it doesn't make sense to. And these dependencies are pretty much just to run Google OSS Fuzz. So what we do is, as we go into a new repository, we try to execute any pre-built script. So for example, some of our projects would have things like CRDs that we need the latest and we need them embedded into our fuzzers, right? So if I actually open this here, so projects within our, org that have this file, this will get executed before the building of the fuzzer, right? So for example, in this case, what we do is we copy all the current CRDs, move that into a specific directory that is needed, because when you're embedding, you must be on a given, it must be a descending directory instead of ascending, for example. Anyways, cool. So if we go back there, so we run any pre-build scripts, we run any post-build scripts as well, which we kind of don't need anymore. But the idea there was every time that you're doing things like with libgit2, for example, you needed to set some environment variables which could affect the building of other projects. So, if those files exist and those files are set here or via environment variables, they'll just pretty much get picked up. Cool. So we look through, we go through every single file, test file, and we check for any function that starts with fuzz, which is pretty much what they should be like when we're talking about Go native fuzz. And as we loop through, there are a few things that we need to change if, for example, you're in a different submodule and so on. But the key thing here is we then go there and call compile native Go fuzzer, which is, built into the OSS Fuzz infrastructure. So that is pretty much that, right? So these will loop through all the targets we have dynamically and make sure that they're all built. There is another version of it, which is based on the current source. And the idea there is, if instead of running this through the integration, which we want to do for the entire org, we're actually doing this on a PR, we don't want you to go against, everything. We want you to go through only the current source directory. But that's pretty much that. Cool. There are a few changes that I'm kind of proposing to this. I actually submitted today, but the core of it is there. On the actual projects, what we have is, and there's some documentation here as well. Every single project that we have fuzzing would have a directory test/fuzz. Within that, you have this documentation, which explains a few things and has the files that we just talked about, right? The Docker file .builder is pretty much just a local Docker file, just to make it really easy to do that build locally, right? So we source the actual build script from upstream, just to make sure that we always, every time that you do like a make plus smoke test, you're actually testing in the same way that upstream would. So, we don't have any sort of, positive or negative failures. All right, cool. So that is the core of it. So if I'm going, on source controller and I want to run the test, so what I'll do is pretty much just run this. It will create the build image and then run the scripts from upstream, which will, again, look through everything locally and build. And on top of building, it will go for every single target that was built and executed once, just to make sure that the fuzzers, they were properly built and they can actually execute, right? Because sometimes there are issues that, and that's not actually the case. So that is that. Cool. So that is that. When we're talking about, imagine something is working here for us, but it's not working upstream. It's not working on the integration, right? The testing on that perspective is a bit more convoluted. So first thing is we need to clone the project. We need to build the image. So, the documentation here explains how to do this, but I'll just kind of go quickly just to highlight. But pretty much you have to build the images in the same way that we do. And what will happen next is, the default behavior. So it will clone every single thing from the actual master or actually main branches, which would be what, upstream will be doing. And then we go and execute the fuzzer. Well, actually, we build the fuzzers. On this case specifically, I'm using the settings that we use for Go, which is using the address sanitizers, and we're building against AMD 64, if I'm not mistaken. But basically what this will do is call the build that we talked about here, so you can see all the repos, and we just look through them. And this will take some time, right? I think mine here got the one from the smoke test, it got stuck, maybe because of my internet or something, I don't know. But this generally goes faster than that. Anyways, this is how it builds and executes, right? For the upstream, so the top presentation there, the top shell there, this is only building, right? After it is built, we actually need to call another command, which is this check build, which will then check the sanitizers across the entire repo. If we look down here, you see that each one of the fuzzers that were built, which were 2, they are pretty much working as expected, which is great. Cool. So this is kind of the core of it. Key things that I wanted to talk about in terms of how things are structured. Things that I want to change to make this better. When we're doing when we actually building things on the CI, we're calling make fuzz, or make fuzz smoke test, which is our internal thing. And what I want to do is to remove that and actually use the upstream action. I didn't do that before because of some dependencies that that we needed to change upstream. So, for example, be able to only compile the current source instead of compiling everything, and all those things kind of changed just recently. So that is one of the things that I want to change soon, which is pretty much here. Updating make file, the make target, choose the upstream base image. I'm still thinking about this, whether we want to do that or not. I don't like the idea of, downloading the Docker image for this, but well, we can reassess that. The only problem with the current approach is that the make fuzz smoke test is there to help you quite quickly reproduce an issue directly on the project in which you have the issue, right? Because we might not be using the same base image, so let me just highlight what I'm trying to say by that. But because you might not be using the same base image, because ultimately they might change theirs. So for example, we're using this base image here, and recently they changed it. If they go and update across all their projects, this base image, the results would be different. Potentially it would still work, but potentially it wouldn't. And ideally they would be always in sync. So again, still thinking about what would be the best way to counter that. But so far we have our own implementation here. What else? Well, we have this native go run. It's not really needed. The idea here was before we were using like the Go native fuzz, but there were quite a lot of things that were like still really specific to OSS fuzz. So I changed that recently. So in theory, we can remove that as well. So once everything's in a good shape, I will remove that. Another thing to bear in mind, and it's also documented here, is that unfortunately, OSS fuzz has some issues when you have fuzzer functions on a file, and you might have all the tests within the same fuzzer. Because what it does is it only uses the fuzzers logic, right? The fuzzer functions logics, which means it clears up the file, before it compiles it, which then means that your imports might be out of whack and so on, which might mean, the whole build would stop working. To counter that, what we're doing is we're actually creating fuzzy specific files. So the files would be like fuzz_tests, especially if you're sharing a file with fuzzers and non-fuzzer tests. And then on those specific cases, if you have duplicated code, unfortunately, you have to duplicate the code, like helper methods across tests, normal tests and fuzzer tests. And just to make sure that things are compiling properly on our side, we should start with go fuzz, libfuzzer, build tags. And I think that is it. That is the core of how things are structured. Overall, we should not have to worry too much about things upstream now, because, well, I'm just submitting a PR. Did I submit that already? Oh, I haven't. Yeah, I don't think I have. But basically, I created one PR, which I actually haven't submitted yet, which will fix a few issues. So, for example, one of the issues I talked to Fide about earlier on today is around this dependency that I talked before. So, pretty much if he introduces new dependencies or change transient dependencies that might break the build, So that would be fixed. And also we'll be removing the Flux CI, because we don't actually need this to detect this is being built on CI, and also to remove the libgit2 requirements, which we don't have anymore. So that is it. That's the key things I wanted to talk about. I wanted to leave, the building running, because that takes a very long time, and that's one of the reasons why we have our quick smoke tests directly into the project, so we don't need to waste so much time building those things. Anyways, that is what I wanted to cover. Does anyone have any questions, any things that was not clear?
Not for me. Thank you, Paulo. Anyone else? This is the last thing on our agenda for today, so unless there are any questions or any other last-minute items, that will be the end of our meeting. Going once? Going twice? Okay.
Oh, yeah, nothing on my side as well.
All right. Well, I think that's it for today then. Thanks everyone for joining us. Have a lovely week.
All right.
Cheers, thank
Have
you.
a nice day, everyone.